What is going on, everybody? This is Anam Shiraz, and this time we will be looking at some use cases of RSA keys. So I will not be going into much details of what RSA is and how the key pairs are generated, but the reason of this video is just to explain you on what different cases RSA keys can be used, because a lot of newcomers get confused in whether to sign the message with our private key or the sender's public key or whatever. So there's a lot of confusion people are getting into. So I mean, as I understood this concept, so like I tried myself to just make a very clear understanding of it and share it with you guys. Now here we have two cases in which we can use these RSA keys. So the first is encryption. Encryption, by encryption I mean that the message will be encrypted. It will not be in the readable form in the communication channel. So let's get started by introducing you very famous personalities in computer science, Alice and Bob. So let's suppose Alice wants to send a message to Bob, and here's the message. And what Alice will do is Alice will gonna encrypt this message with Bob's public key, because public key is available to everyone, as the name says. So, and after encrypting the message with Bob's public key, the Alice will gonna make sure that only and only Bob will be able to read this message, no one else. So let's suppose if the message after encryption is blah blah blah, and it sends the message to Bob, and Bob decrypts it with its own private key, and it can successfully decrypt the message. Now, the important thing to note in this encryption is that if Alice wants to make sure that my message should only be readable by Bob, only then he will gonna encrypt the message with Bob's public key. In that case, no one else will be able to read this message. Actually, no one else will be able to decrypt that message. Here I have written that should only be readable instead of should only be delivered, because Alice can expect that the message can be delivered to a wrong address, or maybe it can be reached by some hacker or any other guy. Or there can be another case where you are broadcasting your message like MQTT or PubNub, where many people are subscribed to the same channel, and let's suppose Mary, Bob and Alice are subscribed over the same channel, and Alice wants to send a message to Bob, but he wants to make sure that this message is only readable by Bob. In that case, if the message is received to Mary, then Mary will not be able to decrypt that message, because Mary's private key will not be able to decrypt that message, because that message was encrypted by Bob's public key. So this is the one use case in which the message is encrypted over the wires. Now the another most used case of this RSA keys is the digital signature, and how it works is, if a receiver wants to make sure that the received message is really from the real sender, that is authentication. Like, you are receiving a message but you want to make sure that is it from the real sender or not, or someone is just trying to fake its identity and is trying to be someone else. And the second thing is that message is not altered. The message that you have received is not altered by something, either by noise or by some hacker or by any other means, and that's called integrity. And the third one is that the sender cannot deny to be the real sender of this message. That is non-reputation. Now, to explain you this whole scenario, I came up with a very interesting example of minions, where we have a king and we have some soldiers. And let's suppose king wants to deliver a message to its soldiers that attack at dawn. And the message also contains the from field, in which it's written that it is from king. The message is from king and it contains attack at dawn. Now it's important to know over here in digital signature, forget about the encryption and decryption. Here you will be signing and verifying the messages instead of encrypting and decrypting. Now the king signs the message with its own private key. Now here is the big difference between the encryption and the digital signature. In the encryption part, we were encrypting the message with the receiver's public key, so that we can make sure that only the receiver decrypts that message by using his own private key. But here, the sender signs the message with its own private key. Now in this case, the message itself can be readable by everyone. So you can say that the message is open, it can be readable by everyone. And once the signature is done, the king will gonna attach the signature along with the message. So now our message is from king, message is attack at dawn, and the signature is some random values, let's suppose. And now when the message is delivered to the soldier's team leader, who is an intelligent guy, who has to lead its team by following the king's commands. Now he will gonna make sure that the received message really came from the king or not. Now the received message is attack at dawn. Really? And if the message is from king, really? Okay, let's see if it is really true or not. Now, now the smart soldier will gonna verify the signature by the king's public key because it has the public key of the king. In fact, everyone has the public key of the king. And if the verified signature is correct, then the soldier will gonna receive a valid message from the king. Else if the signature does not matches, then something is fishy and it will gonna discard the message. Now I will be going into the detailed explanation of how to sign and how to verify the message and how to check the verified message are matching or not in just about a minute. Now let's suppose a soldier does not receive this message and instead it receives the message attack at dusk and the message is from king. Now it has to verify the message integrity and authenticity. Now it will verify the message and it will gonna compare the signatures will not gonna match and the soldier will gonna identify that something is fishy and it will gonna discard the message. Well, what happened in between was something like this. So the message coming from the king was not directly delivered to the soldiers. Instead, what happened was there was another guy in the path, we can call it a hacker, who did some monkeying around with the network. Let's suppose if the network is TCP, it just it tracked the HTTP packets and it diverted the HTTP traffic and by any means it changed the content of the messages and send it to the same destination where the message was originally going. So now you can see that the message is not going directly from king to the soldier. Instead, it's going from the king to the hacker and the hacker delivers the message to the soldiers and it says attack at dusk instead of the original message attack at dawn. Now that will be a false statement because the king is saying to attack at dawn and the hacker is saying to attack at dusk. Now in that case they can lose the war and it will be a huge loss for them. But thanks to the digital signature, that this intelligent guy, the smart soldier, catched the trick that hacker was trying to do. Well, actually, hacker only changed the content of the message, but the from field was still the same. Now, in this case, the signature did not match due to the integrity because the message was changed, and definitely the soldier will not gonna obey this message. So now let me go through some quick steps that how digital signature works. So as I told you that digital signature is about signing and verifying. It's not about encryption and decryption. So the sender signs the message and the receiver verifies the message. And the first thing that sender will do is create a message that says from king and the data is attack at dawn. And it will gonna generate a hash value of the message. For example, h equals SHA-256 message. You can use any hash algorithm if you want. So once the hash has been generated for that message, then the sender will sign the message with the hash value and the private key. So sign, hash, and the private key. And once that's done, it will gonna send the message along with the signature that we made in the step 3. Now when the receiver receives the message, before just checking the signature, it will gonna open the message and it will generate the same hash function with the message. So the hash logarithm of the sender and the receiver should be same. If the sender is using SHA-256, then the receiver should also use SHA-256. Now after generating the message hash function, it will gonna verify the message with the hash value and the public key of the sender. Now let's suppose if the message was altered in between, then the hash function will be different for both of them, for the sender and the receiver. So that will gonna take care of the integrity. But let's say the message stays the same, so our hash function will be same for sender and receiver. But if the real sender of the message was not the king but someone else, let's suppose a hacker, and he just put the from field fakely as king, but in that case he has to sign the message with its own private key, and in the receiving part we will be verifying the message by the king's public key. So definitely the signature will not be the same, because the signature was signed by the hacker's private key and we are verifying the signature by the king's public key. So in that case the verification code will not be the same. But on the other hand, if the message was really signed by the king's private key, then we will be able to successfully compare the signature that we received and the one that was verified at the receiver side. And if both the signatures match with each other, then that means that the message sender is real and the message contents are also real. And I guess that's it for now, and stay tuned for the next part, because in the next part I will be showing you guys how we can sign and verify the signatures programmatically by using Python and JavaScript. Till then, see you guys next time. Hope you like the video, and if you do, please don't forget to like, share and do subscribe. Thank you so much. See you guys next time.